quick introduction to the new features found in the Fall 2021 release of MRIcroGL. And so today we're just going to try to focus on the new aspects of this tool. And so if you're not familiar with it at all, you may find some of the other videos an easier place to start. So in general, with MRIcroGL, you can look at a lot of standard images, and the ones that I will be looking at will be in the File menu and Open Standard. And so the software comes with a lot of cooked-in, pre-available images, and that just makes sure that every user has the same images to look at. So this was me selecting from Open Standard and Chris T2, and you see a T2 weighted scan. And so that's a great way to look at images and make sure that you can follow along and see the same images that I have. The other thing you should know about if you want to automate things or see what this software can do outside of a video is you can always use the scripting menu, and under templates, it will list some basic templates that will load up different images and show you what the software can do. And so it uses Python as its scripting language, and you can see that when I ran it on the right side, it displays a script and it's run the script, and you can edit the script yourself and run it if you want to. But a lot of these pre-built-in scripts will show a lot of the basic features of what you can do with this software. But to begin with, let's look at a couple of the images with this software. And so one of the things that we've improved a lot is the ability to import images from places like DigiSource and MorphoSource that include CT scans of high resolution images. And so from Open Standard, File menu, Open Standard, I can choose the iguana image. And let's display this using one of the new views that's in the display menu called Multiplanar Axial plus Coronal plus Sagittal plus Rendering. So if you choose this option, it will now show you each individual slice as well as a rendering at the same time. And all of the images that are in the Open Standard menu are actually quite low resolution, and that ensures that the software itself doesn't take up a large amount of space on your disk, and it also means it'll be fast no matter how slow and old your computer is. But if you're interested, I'll include links where you can get higher quality images to look at these things. And certainly, this is an example from DigiSource, but a lot of the examples that you can get online are much higher quality than what I'm showing you here. This is a quick and dirty image to show you some of the new features. And so one of the things you can note is if I click on the surface of the rendering view, the crosshairs in the three planar views jump to that location at the surface. So it's a nice way to work out where I'm looking in the object. And likewise, if I click on any of the three slice views, the crosshair that's in the rendering view will show you the appropriate location. And the crosshair in the rendering view should be very salient outside of the object, and it becomes very dim when it's occluded underneath the object. And I can show this a little better by clicking on the lines menu and making the lines a little more bright and visible. So I'll make it a bright red line. And you can see that outside of the object, there's very bright red lines, and inside the object, it's much dimmer. And so this multi-view is a new feature that allows you to have four views. You can click and drag the rendering view to see a different location. You can click on the surface to see that location. And likewise, you can click on any of the three other views to change the crosshair location. And another thing that is standard and has always existed is the ability to change the brightnesses of your image. So if you want, you can try to hide darker material and make it more translucent. And so now we can actually see the bone much better by making the brightness and darkness, by adjusting those values to try to hide or show different values. And you may find that changing the background color to, let's say, black makes this a little bit easier to see some of these renderings. It's up to you if you prefer black or white or any other color rendering you want, but this ability to choose the colors is a very useful feature to try to select out just the anatomy that you're interested and hide the other anatomy that you aren't interested in. And so this is a nice example of how you can get high quality images from places like MorphoSource, and you can view them very easily. And if I right click and drag over a region, you'll see that it will try to optimize the brightness for the specific region that I've selected over. So that's another quick trick, is if you don't want to type in the dark and bright regions, just go over a region of the image that you want to try to optimize the contrast from. It'll try to select a value that it thinks is going to be pretty sensible for that region. So depending on the brightness is under the crosshair, under the selection area. So this is a right click and drag. And if you're using a tablet or other devices, some of the ways to use mice are a little different. And so the help mouse gestures menu can remind you of some of the little tricks you can use using the mouse or the touchpad to do things. So for example, on each of the three views, moving the scroll wheel or doing with a mouse or using a pinch or drag will move between the slices. So as I move my mouse to a different slice, now my mouse is over the sagittal slice, I'm changing slices in the left-right direction. If I put the mouse over an axial slice, I'm moving in the head-foot direction. And in the coronal slice, I'm going to be able to move in the anterior-posterior direction. And you'll also notice that it has an R and an L, just to tell you that in this example, we've got neurological orientation. So neurologists like the right-hand side of a 2D image to appear on the left side of the image, as if you're viewing the object from an inferior location. If you prefer the radiological view, you can go to your preferences and you can unclick radiological view and hit OK. And it'll now switch us to neurological view. So that's a quick tour of the iguana image and also this 4D view. There's some other nice features that we can take a look at. And one of them is the ability to sample along lines. And so if you have an image open, and in this case, I've just chosen File, Open Standard in T1, you can now drag a line with Option. And if you notice on the top of the menu, it will actually show me the position I'm dragging from the left anterior and head-foot dimension to from the start and end of that line. It's saying this line is 110 millimeters long, but it's also now shows a line graph that shows along the 110 millimeters how bright the image is at the different locations. So for example, if I drag with this tool so that now I have a line that's actually intersecting the two ventricles that are dark on this T1 scan, you'll see that the regions where the line is going through the ventricles is darker, so it has a brightness of about 30, where in white matter the brightnesses get to the range of about 120. And so the sampling across lines is a very useful way to look at intensities as a histogram across the line. And just to show you, the other thing you can do with the software, and one of the powerful features of the software, is to look at multiple images at the same time. So now we're right now looking at the CRIS T1. I can load in CRIS T2. And if I want to, I can actually open both images together. And so here I'm going to, depending on the type of computer, the key you press for this might be the control or the command key, but effectively by holding the key down and saying File Open, you can add an image as an overlay. You could also just choose Add Overlay, and that means don't close the image I'm viewing, but view this new image on top. And so you now see in the color bar, the layer box on the upper left, it's saying I have two images open. CRIS T2 is at the bottom, and then above that we have a layer of CRIS T1. So I can hide CRIS T1 or show CRIS T1 to reveal the image underneath it. And right now CRIS T1 is being shown as a red color to distinguish it, but I could display it as a grayscale. So if I load CRIS T1 as a grayscale, I can hide and show that CRIS T1. And likewise, you can hide the background image, but if the both images are hidden, you won't see anything. And if the top image is visible, you tend to not be able to see the background image anyways. But we could select the upper layer, the Chris T1 in this example, and you can make it more translucent. So this is a way that you can try to compare the two images and see how well they are aligned. So by showing and hiding one image or another, we can get some information about it. And the line tool also works if you have multiple overlays. So now I'm actually showing, I've drawn a line that again intersects across the ventricles. So it has both white matter at the start of the line, then goes through the CSF of the ventricles, and then ends again in some gray matter. And you can see that if we look at the lines on the T1 scan, the image gets dark as it goes through cerebral spinal fluid. So water is dark on the T1 scan, but that same region, those same areas are actually bright on the T2 scan. So the line image will show you both the intensities of those values and the relative intensities along the line. So that's a really nice, useful feature. But one general problem with looking at two images on top of each other is while I might be able to make one transparent or opaque on top of the other image, it's still a little hard to see where the actual boundaries are. So what we can do is we can run a filter on one of our images. So I'm going to select the T1 image, my upper layer. I'm just going to say find edges, and it will generate a new image. So now you see I loaded the T2 as my background image, loaded on top of it the T1 as the overlay. But if I did this option menu and chose find edges, it's creating a third layer that just shows the edges. And at this stage, it might even be worth hiding that T1 scan. So now we have the edge based on my T1 scan shown just as an outline. And we're seeing that on top of the T2 scan. So now you can really see the boundaries a little bit better. And you can start to say, are these two images really aligned to each other or not? So obviously on the T1 scan, the edges based on the T1 scan line up very nicely. But if I hide the T1 scan and look at the T2 scan underneath, you could say, how well is the alignment of these two images? Are they really fitting each other pretty well? And in this case, the alignment's really quite good. So this is the same individual, two different modalities have been nicely aligned to each other, so they fit each other very well. Let's take a look at two images that are aligned a little less well to show the utility of this. So I'm going to do File, Open Standard, and let's open the just the Chris T1 image. And then on top of it, in a File, Open Standard, I'm going to load a normalized SPM brain image. And so now in red, it's just the standard space. And just by viewing it, you can see the alignment's not very good, but the red SPM image is occluding our ability to really see that T1. So I can say find edges and make edges based on the selected layer, which was the SPM 152. And now I can really see where the alignment has been poor. And so I can see the regions where, for example, the SPM's image expects the top of the head to be much further up in the head-foot direction than the underlying image. And so we can really compare those two images well. And you can see the size and shape of the Chris T1 image relative to the SPM average-sized brain image. So that's the Find Edges feature. So that's a really nice, useful feature that we have in this new version of the software. There's also some new shaders that are worth looking at. And these shaders, a lot of them are really based on looking at CT scans. So here I'm going to do File, Open Standard, and I'm going to open the CT electrodes image. And again, I'm going to go to the display and I'm going to show the four views, the multiplanar, axial, coronal, sagittal, and rendering view. And so here we have a CT scan, and we can see on the outside that there's a bunch of electrodes on the outside of the skull. And we can also see this brightness of these electrodes that are actually implanted directly against the brain underneath the skull flap. And so this is something where we might want to look at the brain a little bit differently and try to get a better feeling for where these electrodes are on the brain underneath. And there's a couple ways that we can do that. And so one thing that you should know with CT scans is that they have calibrated brightnesses. So as long as the CT scan you have is in Hounsfield units, we can choose some of these different color maps where by default I've loaded this image and it wanted it as grayscale. If I choose, let's say, CT head, it'll choose a color map, and it's going to choose, in this case, the range of darkest as -590 to the brightest of 600. And we can try a different color map like kidneys or liver, and you can see that it's effectively helping us see different surfaces on the CT scan. Since the CT scan has a known brightness, we can choose these different coloring schemes to try to highlight things. So I want to point out this one image, one color map called CT soft, and it tries to show the object as quite translucent so we can see inside the object. And so now we can see something interesting. I can see actually the skull itself and where the bone has been cut to reveal the inside region, and underneath that I can actually see the grid of electrodes that are underneath the skull. So the soft rendering is a nice way to try to see something in much more a classic X-ray view where we aren't blocked by one object. So just to compare that again to these harder views that just want to show you the skull or vessels or different hard objects. And so the soft color scheme is quite nice to have this gradual appearance of different objects inside each other. And that's quite different from some of these harder ways of showing very firm boundaries. If you do look at firm boundaries with CT scans, you may want to try out this tomography renderer. So this is underneath shaders. You have a render button, and right now it starts with the default renderer. The default renderer is a good general purpose renderer, but for CT scans where we do computerized axial tomography, for a lot of the hard surfaces, we get a really nice smooth looking surface if we choose the tomography renderer. So it tends to create a very nice looking surface. So for most of these color maps that we might want to use with CT scans, the tomography renderer works really well and gives us a nice idea of that boundary. It doesn't work with all of them terribly well. So with the soft renderer, which with a standard CT soft color scheme, with a standard color scheme, I showed you how it shows a nice translucent boundary. The tomography forces boundaries to be quite hard, and it will tend to be not very suitable for these type of tasks. So you want to choose the tomography rendering shader if you have a very hard surface that you want to visualize. And another way that we could look at these electrodes inside the brain is to open up a clipping plane to look inside the brain. And so we can choose the azimuth of our clipping plane and the elevation of our clipping plane to try to take a peek inside the skull and see where the electrodes are relative to the skull. So that's another nice way that we can look at things, is by cutting out a clipping plane. So the tomography renderers are really a nice way to look at CT scans. And we've done a lot of work to try to make CT scans look better with this tomography renderer. And the software comes with a few standard sample images to try to show you CT scans. So the CT abdomen scan is a nice one for showing things like the kidneys. And so this is a chest image where we can really see that the person has their kidneys that are shown very well because they've been given a gadolinium contrast. They're very distinctive and easy to see in this particular scan on the rendering. We can see the kidneys very easily with this rendering. And that's a very different type of surface than if I chose, let's say, the surface of the body, and we saw what the outside of the person's body looked like. There's also some nice standard CT scans that show you things like venous malformations. So this is a scan that's really trying to show you blood drainage and show you where the blood drainage is, and we see a malformation in the left parietal region for this image. And there's also a standard high quality CT image of the skull from Philips. And again, a very nice classic skull scan, this one without electrodes in it, where we can look at these different views and look at different tissues in this scan and try to get a good idea of what this scan looks like, what the different tissues are like. And again, we can choose both the surface, and for most CT scans, the tomography renderer is a nice one to use. So Open Standard includes a lot of new features of new scans that are included with the software to try to demonstrate what the software can do. One of the scans it includes is a arterial spin labeling scan, PCASL, and this is a 4-dimensional scan. So in this scan, we have actually 3 different time points. So that's why when we load the scan in the layer map, it says right now you're viewing layer 1 of 10. And we can choose to see which of these 10 volumes we see by choosing previous or next volume from the display. And so we're seeing different time points for this image. Or we could animate this, and so we can have the computer automatically shift through different time points. And it's worth saying when we look at these 4-dimensional images where we have different volumes across time, that by default the software will show you at the bottom a line graph, which each line showing you a different time point. So in this case, I'll make this line graph a little bigger. We can see our different volumes. We have 10 different volumes, so it's labeling them from 0 to 9. And the vertical red bar shows me which line I'm looking at this moment. So I can actually choose to look at, let's say, volume 6 by clicking at the 6th location, and it will show me that volume. Or I can look at the very first volume by clicking close to 0. And so the line graph can show me something about how the image is changing across time. And this can be useful for trying to find outlier volumes, to try to find a time point that's unusual that might need correction or something's gone wrong. And it can also help me get a little bit better understanding about what my data looks like. And in this case, the data is in general pretty noisy, which is common with arterial spin labeling. But you notice that in a lot of locations, like the one where I've clicked now, there's a very seesaw shape of odd versus even images looking differently. And we can see that that's not true with every voxel. They're kind of noisy, but in general, we see this sort of a pattern of a sawtooth pattern. And for arterial spin labeling, this is actually what we expect, is that we pair images where we apply a label at the location of the neck, and only the stuff that moves from the neck to the brain will be blood, and that blood, since it's tagged, will be darker than if the label wasn't applied. And so we have pairs of images that either apply a label or are control images where no label's applied. And we expect the labeled images to appear darker, and that allows us to infer blood flow. And one thing we could decide to do is, since each voxel is a little noisy, if we want to identify which of the pair is the control and which is the label, we can always draw an object. And it's easy, there's drawing tools here where you can use a pen to draw specific colors. But if we want to just do a very simple drawing, we can decide to do an automatic drawing, and we'll decide to draw a ball shape, and we can decide how much we want the ball to be constrained by brightness. But let's just put a ball, and so I'm going to click the cursor in a location near the center of the brain, and if you hit reset origin, it will move the cursor location, so it's now drawing a ball at the location I selected. And so we now have a round ball that's about 32 millimeters in radius, and if I apply this, I now have a drawing that I can look at. And these drawings, if you want, you can make them opaque. You can show them or hide them by adjusting their transparency. But the other thing you can do is you can go to the graph and say show intensity under drawing. And now it will show us the average intensity for all of the voxels put together that are selected in this drawing. And now we have a much stronger signal. So we're averaging a lot of noisy voxels together, and we can really see that sawtooth shape very well. So that's a nice feature to allow us to inspect our data and look at this timeline and get something reasonable out of it. The final thing I might as well go ahead and show you is the atlases that are included with the software. And so if I load an atlas on top of the image, and so I can do this by file, and then it has add atlas, and it has a lot of standard atlases, you can notice that it's drawn a translucent image of different regions over this brain. In this case, these regions aren't very well aligned. I'm going to do file, open standard, and let's open the SPM 152 standard shape brain. And let's add our atlas. We'll choose the AAL atlas in this case. And it's now loaded the atlas on top. And so again, I have a layer of AAL as the top layer. And if I want, I can hide or show that top layer or adjust my opacity to make it more or less salient. And when I choose an atlas, the software gives me a set of locations beneath where I can see all the structures of the atlas. So if I wanted to see, let's say, the right fusiform gyrus, I can click it and it will tell me the volume in voxels, its index, or what number it's given in the atlas, and it also tells me something about its location. So it's telling me that this is on the right side, slightly posterior and slightly inferior. So that's my fusiform area on the atlas. And so you can click on different areas to find these regions, or I can actually just click on the image itself, and you'll notice in the upper right, it's saying that now the cursor is selected at the parietal superior right. So the superior right parietal cortex is the location that I've selected. So these are handy ways that you can look at images and see some of the information about your data very easily. So that's a really quick tour of MRIcroGL and a real focus on some of the newer features that we've added in with this release. So look at some of the other videos for some of the more classic features.